Okay, guys, we're going to solve this quadratic equation by completing the square. When I work through this equation, I'm going to ask you a lot of questions. I'm going to give you time to pause and really think, and I want you to give me an answer. Even if you're sitting at home by yourself, I want you to make this a real experience. Okay, so if I ask you to solve this quadratic equation, perhaps you would solve by factoring. Perhaps you would solve by using the quadratic formula, finding your A, B, or C term. But today we're going to solve by completing the square. Okay? It's great to have as many different options as possible. So the first thing I want to think about is I want to create a perfect square trinomial. I'm looking at this 5. This 5 is not making me happy. This 5 is not allowing this to be a perfect square trinomial. So I want to get rid of the 5. Think about, how do you get rid of plus 5? Think about it. How do you get rid of plus 5? Go ahead and answer me. Absolutely, you have to subtract, right? Okay, so let's do that. Perfect. Do you see what we're going to do? And it's exactly what you said. We're going to subtract minus 5 to get rid of it. Beautiful. Easy enough. Okay, now that we've subtracted 5 from both sides to keep it in balance, do you see that I left some extra space here? Why do you think I left a little extra space here? That's right, because I want to put the one number here that will allow this to be a perfect square trinomial. So what number goes here? Think about it. You have the power to put any number you want there. What is it? 9. Absolutely. 9 is the only number that will create a perfect square trinomial if I have a 6 here. Do you see that? Because 3 times 2 is 6, and 3 times 3 is 9. Another way to think of it is 3 plus 3 is 6, and 3 times 3 is 9. Do you see why 9 is the number that allows me to have a perfect square trinomial? Great. So, oops, I forgot to put that 5. So, if I add 9 to this side, I have to add 9 to the other side to keep it in balance. Does that make sense? Okay, good. Now that I have this 9, beautiful, I can easily factor it because it's a perfect square trinomial. How will this side look when I factor it? Let's check that out. Well, so far I just combined these. Negative 5 plus 9 is 4, okay? Now I'm going to factor this side. Staying with me, you guys? Awesome. Do you see that? Do you see how x squared plus 6x plus 9 can be factored as x plus 3 squared? Okay? If you wanted to, by the way, before you see that square, I want you to imagine that, remember, this is x plus 3 times x plus 3, which can be solidified as x plus 3 squared. Remember how we were talking about 3 plus 3 is 6 and 3 times 3 is 9? Okay, and that's why we chose to place 9 here. Because of that, we can easily factor it as x plus 3 times x plus 3. Does that make sense? Any questions? If so, jot down your questions now. Beautiful. So far, so good. So we got rid of the number we did not like. We added that one special number to both sides, and now we can easily factor it. We're in a really good place now because now that we have x plus 3 squared and we want to isolate the x, we simply need to get rid of this square. We need to get rid of this power of 2. How do you get rid of a power of 2? What's the inverse of squaring something? Think about it. What's the inverse of squaring something? How do you get rid of it? Did I hear you say take the square root? Beautiful. Absolutely. You guys will notice my font got a little bit bigger. No big deal. So do you see that I take the square root because I know the square root will undo the square, and I will only be left with what's under the radical, which is x plus 3. That's super cool, right? But remember, if I take the square root of one side, I must take the square root of the other side to keep it in balance. Okay, so can you imagine what our next equation will look like it's the same equation, but as we continue to simplify it? All right, let's see. Actually, oops, forgive me for that. Okay, so how will this look? We're simply left with x plus 3 equals plus or minus 2. Does that make sense? Sorry about that once again, guys. Okay, does that make sense? Remember, square root undoes the square, so I'm simply left with x plus 3. And then the square root of 4 is 2. So do you see how I'm left with 2? So let me read what we have. X plus 3 equals, do I need a double equal sign? No, sorry, made a mistake, but I am not going to redo this because I know you're with me. Great. So we have x plus 3 equals plus or minus 2. That looks a little strange. Let's rewrite it as two separate equations. You see how instead of writing it like x plus 3 equals plus or minus 2, I can write x plus 3 equals 2 and x plus 3 equals negative 2, okay? That is all this is saying. They want you to set it equal to a positive 2 and a negative 2, so we'll do that. X plus 3 equals 2 and x plus 3 equals negative 2. Now let me just solve each equation. Minus 3 minus 3. 2 minus 3 is negative 1, so I have negative 1. Minus 3 minus 3, x equals negative 5. So my two solutions are negative 1 and negative 5. All right, are you ready to try one on your own? Okay, there's a lot of steps, but I want you to think about the reason that you're doing every step. Okay, ready for more? It is